Pleasure to be here. So, a quick overview into the way the status of manufacturing is today and what could be transformed is what we are going to discuss, or kind of I'm trying to walk through today. So, the sensation today in the world of manufacturing is how do we kind of do gigafactories, concentrate most of our manufacturing activity into one large form factor of a real estate. But if all of you had a lunch, we use some tools to have a lunch, right? So these two are two objects made out of the same material, right? Except, if I ask you, are they both same objects? You would say no, they both are two different objects, right? To make these two objects, these are the kind of machines that are needed for you to build them today, right? In contrast, you also have a device in your hand and it has two apps, right? Each of them consume entirely different kind of data, entirely made out of different kind of code, different kind of setups, but yet they are produced out of the same machines, right? Today, what are factories? Factories are magical hands that you put into the earth and then extract the raw material into a shape that is of utility to you, right? Except when you have to go about building those factories, why is that we are not able to simplify to one simple machine to produce both of these different shapes that you are making out of the same material? And why do we end up building something complicated like this, right? So this is a Panasonic, Sony PlayStation, which you will be able to recognize, and it's an automation cell that has come up for a PlayStation. So this is done by Panasonic, possibly took 3 years for them to build it. You also recognize, after you recognize this PlayStation, you also notice that there is a cacophony of engineering being put together, complex machines, complex pieces of sensors, wiring, and everything comes into it. Now, you would wonder that this must be doing something very sophisticated, right? A complex, task. All it happens to be that it's doing a horizontal to vertical flip, right? A person would have just picked it and then done a flip. Needs this much of engineering today for it to happen autonomously, right? It's not even autonomous, it's automation, essentially, right? So, if tasks are so complicated, every time when we thought about assembling pieces and assembling parts, we have ended up building variety of different machines. Every new task that we come across, we end up building a uniquely different machine for them, right? So the question comes to then to focus on the tasks and then ask what is different in the tasks, right? If you want to think about a general machine as good as a laptop, then you have to generalize all your types of processing into one standard form factor, right? You can't have variety of tasks. The more you see each task as different, the more you end up building different machines. So you need to start something universal between them. So in every task that you notice here, this is a simple, from a kit, a person is picking these parts and he's putting together. In every of these tasks, you notice that it's a combination of picking, orienting, and placing. And this consistently comes about in even such complex tasks. If you notice from engine assembly, where all parts are picked from random bins and random orientations and presentations, and you have to bring it to an expected orientation, right? Your pen and cap has to be in the proper fashion, else it's not complete. So every time to complete a task, you need to bring objects of different, natural state to an expected state, right? Now, this is what happens within the industry today. Robotic arms, to be able to be adopted, to be able to automate these kind of manual tasks, are mired with a problem of customization. Industry suffers customization sickness. Today, 70% of the value lies in the customization around the arm than the robotic arm themselves doing something meaningful for you, right? So, at the best, these arms are a 3D conveyor belt that move parts from one location to another location. It's a record and playback machine. If the part's orientation tilts by a small amount, they don't know what to do. They go and foul on the part or they default, right? So this is how limited it is, and to ensure that those parts come in that expected, programmed, exact orientation is what you're going through this. And this is another reason why the industry is very small. Today it's a $48 billion industry. In 2019, 44 in 2024. And out of which only $16 billion is for arms, or the industrial robots, right? Remaining is all entirely invested into customization. Now for a customer, he has no assurity that the amount that he has spent on these automation cell is going to result in something meaningful. 70% is experimentation for him, right? So which also increases the barrier of adoption to the customer. And anytime he has to do, globally in developed nations, it's anywhere between $150,000 to $250,000 to make one cell possible. And none of this is repurposable and reusable if something changes in your parts. So you need to have visibility that for the next 8 years, 9 years, or at least 5 years, the parts do not change. Imagine a mobile phone where you have the versions changing every year. And how do I justify this much investment that goes into that system, right? So this also limits my infrastructure and factories to be a lot more stringent and rigid. On the other hand, we have witnessed this many a times. This is a beautiful, GIF that talks about how all those devices used previously for data processing became just one form factor, right? One confined form factor. Now, what would it take for us to have a software-defined factory than a hardware-defined factory? The step starts with somewhere you need to have a standardization. You can't be dependent on variety of different hardware and components for you to solve a problem, but you should have one type of hardware which you could just keep reapplying into different kind of tasks that scales seamlessly between all the tasks, right? And that's what we focus on. And what we have to also notice is, we talked about how pick, orient, place is what is the combination of a task is. Today, the approach for the industry to solve it is, before I pick, the orientation must be fixed, right? So the orientation of the object should not be altered, right? On the other hand, if only the robot is able to pick from its natural state without worrying about the orientation of the object, you largely solve the hardware generalization issue, right? So what it takes is a robot that picks without learning, right? So this is a good video of an World Economic Forum coverage on what we actually do as the concept of universal factories. So in every case, we need a system that could scale across unseen, unknown objects across variety of tasks, and it should be equipped enough as a universal form factor to perform any task that you may need, be it from picking a spoon or putting together a pen or assembling a car or even let's say a mobile phone, right? So, and that ability for the system to scale across every variety of tasks that you have within a factory makes it as the first building block of a factory. And a factory that's made out of that becomes versatile enough to produce back-to-back any type of products. Like imagine all models of a car happening out of the same line, or models of the mobile phone happening out of the same line, and how much you would be able to condense the cost for the customer today, that a simple automotive line for a particular car model consumes $300 million to $1 billion, and it's indefensible for him unless and until you are meeting a 30,000, I'm just throwing a number, let's say 30,000 pieces per month, right? On the other hand, market is not willing to absorb those many robots. Then what do you do? Cars. Then what do you do? You need to introduce more models, and each model consumes another line altogether, right? So this becomes a demand creation issue at every point. What if that could be eliminated? That on basis of a demand, you can repurpose the same line across all platforms, not just models, all platforms of cars, right? So that begins with a robot having a fundamental ability to pick any object that you throw in front of it without any prior training. Every object that you would notice here, the robot has never seen them before, no training, no machine learning training prior to it. It's a system learning on the live. So what you're witnessing is a robot like a baby without prior knowledge of the object going and picking them. Each of the objects are different heights, different softness, different thickness, different weight. How does it even know where to go apply how much force, right? Beginning from there, we even have complexities that will lead to situations of lighting variations. One of the other problem then when people want to adopt robots, putting a camera on top of a robotic arm, making it more universal, what you trained for morning, it doesn't work for evening. So if the lighting changes in your factory from morning to evening, the robot's actually fault, right? So this is a bigger bottleneck for customers today also to adopt the advanced technology that goes on top of a robotic arm, that we are facing a barrier of you need to train the system every time on every corner case that it may happen, right? And for the robot to be able to act on them. You also have this complex situation where a completely random set of objects are put into a wrapper. There is no color consistency, there is no object consistency, there is no prior knowledge of these items or the combination of the items that you can feed to a robot. If the robot achieves this feat within 10 seconds, it's able to kind of figure out, you will see the timer running, it's able to instantaneously figure out how to kind of go grasp that whole object like a baby would do. A baby may not know what it has actually grabbed, put anything in front of it, it'll pick it, put it in its mouth, throw it out. You don't have to teach them or program the environment so that it can go exactly to that position, pick it in a certain way, and then place it in a certain way, right? So this allows for customers to be able to solve issues or the tasks which cannot be controlled in the environment, like putting together a car's door or a car's chassis or your mobile phone screen. You can't predict how the wires will behave. You can't predict how those parts that attach on top of them would behave. Yet the system is supposed to seamlessly, act on them. So this inherent ability for the robot to, without any prior training and prior learning, to go grasp an object, learn on the fly, is the breaking point for you to enable a standardized hardware that can just transform your factories to be universal enough, right? So I'll just skip this. Founded on these basic, infrastructure, we have 3 different product lines that we start with. So humanoids today are a lot more leg up in their approach. What we are trying to do is to go head down to see what is that enables a human baby to act on an object without knowing what it is, without using its vision. So we start with the head that we custom build entirely from scratch, including the vision and the visual ability for the system. That on top of a multi-arm system, which mimics some portions of freedom, but something more extra than a human being to act in real world, in whichever the way the presentations and complexities may come for you to kind of handle. The third part is a mobile platform, which can also move, which we'll be releasing by the next quarter as a beta version. And by 2026 first quarter, we will have an official release of this product. So it's a Synoid is what is the platform that we call, which can be mobile and then can handle a lot of other situations that occurs inside your factory. So the visualization of applications for us is starting from how you would begin with basic pre-assemblies, where it has to go find out where the parts are, pick them from its natural state, anything that may have changed within, adjust itself to it, and perform the expected task on top of them. From there to situations where today we had Dr. Werner Vogel's last September in our office, Amazon's CTO, global CTO. So one of the big problems that we are quoting is every month they have close to around 500,000 SKUs change. The parts keep changing. They can't be training for each of this. You need a system, just like a human being, without knowing what it's picking, can go pick them from its natural state and then perform the task. Second, most of them come with a wrapper. If you have a wrapper on top of an object, what color pattern am I supposed to look at? Right? How am I supposed to understand what I'm actually picking? So a system that can seamlessly understand the variations that may happen in the environment without knowing what it's picking, it will pick it, understand that orientation of the object is right, and then be able to perform the rest of the taught task is another application, what we call as kitting, essentially. And scaling all the way up to a concept of a complete factory being taken over by one form factor of a machine. You do not see any other variety of machines, just one machine, scaling from your logistics center to your warehouse storage centers to your sub-assembly and pre-assembly to your entire car chassis assembly. This could also scale to every other discrete manufacturing that you may come across. Could be your white goods assembly for your refrigerators, for your TV, or it could be to your mobile phones or any such devices and machines that you may come across, right? So the idea for us is anything that you want to change in your factory, you don't have to go and touch your hardware. No infrastructure change. It's all just a software change away, right? So it's one form factor. You change the software, it just goes about performing the rest of the other tasks as if it was performing it every day, right? So the foundation, our approach to autonomy is 3 layers. Starts with hardware standardization first. So just like how laptops had a standard data processing unit like your ALU and CPUs, So what does that look for an object computer, right? Instead of a data computer, if I have an object computer, what it will look like as an hardware? And then exploiting it to build a sentience platform. What we mean by sentience is a layer before intelligence that without knowing what those stimuli are in the external environment, they can still go and interact with them. You don't have to know that object to be able to touch them. Without knowing what it is, it can pick it, understand it, then kind of combine that intelligence into it. And the last part, what is most interesting that will come about is the future of or equivalent of what app stores are today, right? Every time it touches an object, it understands what that object is, and it also learns what the task that you have actually taught it to do. So you create a library of these tasks and object tasks, right? So the customer can, so if he has a robot, let's say customer A has bought a robot, and somewhere else, customer B has bought that robot and he has taught how to pick a bolt, he can upload that teaching that you have done in that robot, like a program, into the system, and a customer elsewhere will be able to download this, pay and download this and start using it instantaneously. Your same robot starts scaling instantaneously. No hardware, form factor changes, no modifications, no laborious 36 months, dumped into all the infrastructure changes that you may have to come, that you have to do. So I'll just skip this too. The final vision for us is largely within this idea of what object stores leads to. A task is a composition of knowing the object, like a bolt, and the spanner, which is the tool, and then knowing how to apply them. In this, the IP of the customer lies in the work models that he actually builds. An equivalent of that, you can imagine, you went to, let's say, Thailand, and then you had an amazing, dish. The person who invented the recipe, he now has a lifetime customer, but if you ask to monetize that, he has to set up a shop here, brick and mortar here, create another, demand for 100 other customers to come in daily, and have all this local material sourced. Now this becomes impossible for him many times to monetize what his, IP was. On the other hand, imagine you have like something like a Zomato app, and you can order from Thailand and it just comes through fiber optic cable, right? It's not the food that comes, but the instruction to do that comes. And like your laptop, you have your robot system within your space. Whatever the recipe they taught with that same system on the other end gets downloaded here, and then you can start, cooking them and then making them. So recipes of tasks, recipes of any IP that you do physically, essentially is a recipe of a task, right? And then you have just had a unique way that you have put together. Now you could globally monetize them. So that's a bigger vision that we actually get into. On the other hand, one of the most important thing that comes about is today NLPs are incapable of, or whatever that we talk about in terms of AI and ChatGPT, versions are incapable of understanding what verb is. Because machines have never touched and felt the physics of the real objects, right? And that's what we try to, bring in. The more the machines learn physical world and physical signals, the more they can understand in a more multi-dimensional way of what it actually sees, what that color means, what that sound means, right? So that's where we are getting into, and that's our larger goal, to get into the vision of universal factories, which in your later versions need not be large gigafactories, but broken down small micro universal factories that you can convert your service centers into factories that will customize everything as to the consumer's needs. So the vision that we have is the factories can start producing customized products, then having rigid fixed products, right? And what it evolves for the customer tomorrow is they are relieving the design from the clutches of manufacturing, which means to the velocity of what the consumer needs changes, every manufacturer can adapt and quickly and then start exploiting the value for whatever the ideation that they have come up with, right? So they are not fettered by the limitations of manufacturability every time when you're imagining a new idea or a new design, right? So we are a 65-member team, touching close to 80 by this year end. We have a design office at Switzerland, and we are from Bangalore here, right in Whitefield, right here. So this is the 14,000 square feet of lab that we have, possibly one of the well-equipped robotics R&D lab in India. And we recently have also opened up a sales office in Texas. So currently our partners are, we have gone to market this year, and we have Audi and Applied Materials as partners at this point. We'll also be scaling more to furthermore customers soon, and these are our partners. It's ridiculously large is how we actually imagine. this, right? So if you just think about US alone, it's the manual labor wages are around $1.3 trillion. This is little older data, 2018 to 19 is what I remember. Right now it might be even higher. And manufacturing alone, in US alone, pays close to around $230+ billion of wages annually, right? So there is a large untapped space. And compared to that, today, robotics market, if you see, robotic arm market, if you see, industrial arm market, if you see, is just a $16 billion market. It pales. And it has remained so for stagnated for a very long period of time because they have focused only on welding and painting, and those are the larger ones. And they don't scale for dynamic activities where the robot has to know what to do in line with. So this mirrors a humanoid market. So beyond software, which is around like $12 trillion or so, if my numbers are right, but rest of the GDP that you largely think about is all factory made, including the air that we breathe now, is factory made. So all these are somebody assembling the parts. Outside of process industry, what we call as discrete manufacturing is what is our larger play of market that we're hitting at. So that should be the total market cap. The wages paid in there should be the total market cap that you could exploit. What we are more keen is not what we could borrow today, what it can expand further into. What it will enable factories to build more, and what it will enable factories to create more value with. So that is something that we don't, it's a green field, we don't know what it will scale into. The market must tell us from the front. But current market is, this is the reference for us. Building the framework into the system, first adoption has to happen. Like you need to put iPhone in everybody's pocket, then App Store makes a lot more sense, right? So what we have is an inherent ability to kind of extract everything that you teach as a program that you can actually store. And we are building a full framework to make it much more easier. We are, in all honesty, we are a nascent technology company, nascent product company. We are also building that whole framework. As more customers adopt, it will, the churn will happen more. So we have the infrastructure. What we need is adoption happening around that. And more parts being trained, more tasks being trained, then customers can start uploading more, which will also give us a lot more feedback to stabilize that whole infrastructure and the software and layers within them. So plus, all said and done, this hardware is also slightly immature because the supply chain in itself is non-existent. This is an industry that is non-existent, which means you don't have like today I have a problem of building a car with cycle wheels. All that is available is cycle wheel as supply chain, right? So that response from supply chain is also needed. So it will take its time to get to that maturity, but even at early stages, we are trying to mirror the models that is there for the customer convenience. So you will have a centralized repository where it is uploaded. And so in fact, if it's deployed in your factory, you don't have to bring the robot every time to my facility to train it or to send it to your system integrator's facility. If he has his own robot, you just have to replicate this scenario. Whatever he trains there could be downloaded and then put live into your robot system in your factory, operating in your factory. So that way debugging also can be remote if there are issues that is happening within your line. So